So how much energy eclipsing interaction for eclipsed form compared to staggered form? Yeah, you are not hearing me?
Sir, for ethane,
Yeah, for ethane.
3 kilocalorie.
3 kilocalorie.
Yeah, because these three hydrogens are eclipsing each other for 1 kilocalorie for each of them. This is the theoretical value, but experimentally we get a value around 2.9. That's okay. So what is the least energy conformer here? For ethane, it is staggered form. Well and
Staggered
up
form.
to up to this we are fine. This is what we have done in the previous class. So shall we move to the today's class? Today's class we will talk about butane. Okay, so just look into the butane. Butane exists in these four forms. Okay, this is the Newman projection. So you can keep this. Basically, you can have these three conformers where you can rotate one of your methyl, which is in the front carbon, and you end up in getting this four forms. This is very nice. Okay. What are these forms called as? Any idea?
Fully eclipsed.
Gauss form.
Come on, man. So what is the first form called as?
Fully eclipsed.
Fully eclipsed.
Yeah, it is a fully eclipsed form. Very good. You used the right word, fully eclipsed. What is this form called as?
Staggered.
Staggered. Now we have these two forms. What is this form called as?
Gaussian.
So Gaussian.
Gauge. This one?
Partially eclipsed.
Partially
Partially eclipsed. Okay, nice.
Sir,
Yeah.
what we
Yeah,
call, sir, what we call fourth as NP.
this is staggered. You can call us anti also. Very good. You can call us anti also. No problem. Okay. That's why I want to go and show the real names, what people call scientifically. Okay. The first
Sir.
one is yes. Yes.
Sir, we can make Newman projection between any carbon now. Why we have taken middle one bond?
We have to take with C1 and C2, C3.
Yes, sir. Why that one?
Because that is then otherwise you will have three hydrogens. You cannot explain the eclipse staggered pattern. Okay. Always take between C2, C3. So it is very, very nice to show all your staggered. You can take any way you want, but you have to take the best way from which you can explain the conformers, the steric interactions. Okay. That's why this is the best way to show it. Fine. Okay.
Okay.
Yeah. Now, what is this first form? We said it is staggered, right? But its best way to call them is to call them as an anti-periplanar. This is the word people use frequently when we communicate with others. We don't say staggered form. We always say that it is an anti-butane. Okay, that's how you have to buy. Sorry, for when you write a paper, to communicate. You say it's an anti form. Okay, anti means people know that it's a staggered. Okay, where two methyls are apart. It just in this slide we will just consider the names only. Okay, don't think about others. Okay, the second you call them as a gauge, or you can call them as a synclinal, or nothing wrong in calling them as a gauge, because gauge is very common. People call them as a gauge form. B is the anticlinal form. Okay, that's why we call that synclinal, because B will be anticlinal, and the D will be fully eclipsed or syn periplanar. One is anti-periplanar. Okay. Another is syn periplanar. Syn periplanar only will be called as fully eclipsed. Anti-periplanar can be called as anti or staggered, but staggered people don't call it. We call them as an anti-periplanar, syn periplanar, synclinal, anticlinal. These are the words we use most of the time in the butane. Okay, but anyhow, just it's good to remember this name. People are not going to ask any question on this basis, but you should know if it is synclinal, you should know it's a gauge form. Okay. And hello.
Yes, sir. Yes, sir. You are audible.
Yes, sir, you're
Yeah.
audible.
Okay, okay, fine, okay. Now I have 4 forms. Now the question comes for you is that, you see, I told you we are not going to examine your retention skill by asking, write the name of this form, write this name of this form. No one is going to ask you. We don't want to check your retention ability or your memorizing ability. We want to check the energy, right? So now you have to tell me the energies of all these forms, because I have teased you hydrogen eclipsing with respect to the lowest form, least energy conformer. I will put this word very clearly. See, I'm using a word least energy conformer. I am not using a word minimum energy conformer. These both are entirely different, and you guys do many mistakes when we ask this question. Please remember, I'm talking about the least energy conformer. Okay. So which is the least energy conformer here?
Anti-periplanar.
Okay.
Anti, sir.
Yeah. Yeah. You keep this as 0 with or 0 with reference to this. Not, I don't put the value 0 with reference to this. You have to tell me what are the values of this. You write it in your paper now. I will give you just 2 minutes. Just write it in the paper and we will check whether your answer is right or not. Because I have given you all the values. You know all the values now. Take synclinal form, write the values. Take anticlinal, write the values. What should be the energy kilocalories per mole? Syn periplanar, write the value. Definitely you will have questions like this. I want everyone to write it. No escapism. At least while writing, you will remember the calculation. 1, 1.5, 3. That's all you have to remember. And 0.9. Done?
Yes, sir.
Everyone done?
Yes, sir.
Okay. If everyone is done, I'm going to show the values. If you are not done, please tell me, sir, I am not done yet. See, when you solve something and देखना में मजा आएगा तो अच्छा. Yeah.
Done, sir.
All are done. Okay. Fine. Then I'm going to the slide. Okay. Check the value of this. So this is the least energy conformer. Okay, the C. Gauge form is how much you got?
Yes, sir.
So
0.9.
0.9. That is for gauge form. What is for your anticlinal?
So 3.8. 3.
So this
Nearly
is,
equal to
yeah, this is
3.8.
what.
Near
3.6, sir. Sir, 3.6.
Don't, yeah, the value which I have given, that is enough. So this is how much? 1.4, 1.4, 2.8 plus 1, right? 3.8. Yes?
3.8.
Very good. So this is
5, sir.
5.
this is
5.
3.
Yes, sir.
Yeah. So you got it there, right? Can you tell me something something is missing here? It's exactly 5.
Excuse me, sir.
Yeah.
Sir, hydrogen interaction is 0.8 or 1.
You calculate with 1. That's enough. Okay, don't worry about that. We know that. We don't go with that fraction number. Okay.
So if I calculate with 0.8, then will it be wrong?
Why?
No, sir. Just I'm asking.
That's why I'm telling you, we know that when we set a question, okay, 0.2 kilocalories, we know that what to do, okay? These are all not, you cannot set a question with the experimental values. Theoretical knowledge only, we have to find it out, okay? So keep it to 1. That's fine. It comes well and good. Hmm?
Okay, sir.
So anyone went wrong in this?
No, sir.
If you have went wrong, please let me know, because you will get a question definitely from this type of things. Then don't ask me. Sir, it will be straightforward, sir. Okay. Now I will ask you one question here. Be careful, listen carefully what I am asking. Which is the least energy conformer in this? Which is the least energy conformer?
Anti-periplanar.
Anti-periplanar. Very good.
Anti-periplanar.
Okay, now I am asking you another question. Which is the minimum energy conformers here?
Sir, Gauss.
The Gauss and anti.
Very
Gauss.
good. No. Gauss and anti. Don't make a mistake. Okay, the least energy conformer is anti-form. Very nice. No doubt. But once you go for the minimum energy conformers, okay, even 1 kilocalories can exhibit very nicely in the room temperature. That conformers are exist. That's why we give that 1 kilocalories always an option. So that's why you can consider Gauss also to be existing in the room temperature. So the minimum energy conformers are what here? The minimum energy conformers are anti as well as Gauss. Clear? So the least energy conformer is anti-form, no doubt. Minimum energy conformer is anti as well as Gauss. Both will be exist in the room temperature. Anti form also you can see, Gauss form also see, because it is only 0.9 kilocalories. So they also will exist in the room temperature. So both will be there. So that's why when we ask minimum energy conformer, please put your brain in and say that it will be anti and Gauss. I am teaching this many times, and the many times this question comes, you won't see the question at all. You will immediately write anti-form. We might be asking minimum energy conformer. Gauss and anti both are minimum energy conformers. If I ask least energy conformer, then you should write anti. That time don't write Gauss and anti. Understand the difference. Least and minimum. Okay?
So those who have energy less than 1 kilocalorie are considered as minimum.
Yeah. You can go for them.
Sir, is this 1 kilocalorie limit for the minimum energy conformer set only for the butane conformers, or it is set for conformers of any other organic
Many other
compounds?
Many other compounds. You can go for
Okay,
it.
so for everyone, 1 kilocalorie is the limit for the minimum.
Less than 1, not 1, less than 1.
Yes, sir, less than 1.
Any doubt with butane? So in butane, if you want to ask what type of questions we can set you to find out the energies, which is very important. Potential energy. We can give you that. We can give you a synclinal form, or we can give you the anticlinal form, or we can give you staggered form and ask you the energies. How different it is from the least energy conformer. What will be the energy of synclinal, anticlinal compared to least energy conformers? That will be one type of asking. Or we might ask you which is the least energy conformer or which is the minimum energy conformers. Okay, these are the things you can expect. And you might ask what is the Gauss interaction? How much energy is Gauss interaction is? Gauss ka energy is how much? Or we might ask what will be the interaction of methyl energy. Okay, clear? If you don't have any doubt, then only I'm going to proceed, because you can definitely have questions from here.
Sir, how are we calculating the energy for Gauss?
How we are calculating is 0.9 kilocalories.
Yes,
how
sir, that's how we are.
Experimentally.
Okay.
You're asking experimentally or what?
No, sir, in the other cases, we are finding the values from the given one, that is the HH interaction, but how we are calculating for Gauss?
Gauss also, I told you 0.9. That time itself, I told you, na?
Yes, sir.
Yeah, I told you. No, I didn't got your question. Can you? I don't know where What question you are trying to ask me?
No, sir, I was saying that with the reference of the HH interaction or HCH3, we are calculating the energy for fully eclipsed or partially eclipsed. But
Yeah.
for the Gauch one, you have given the values, sir.
Yes, yes. That is also, it is, we consider that it is little bit lesser or it is equivalent to hydrogen-hydrogen eclipsing interaction. That's how we got that idea, 0.9. Okay, experimentally. Fine?
Yes, sir.
Okay. Now, so butane I am done, sir. Okay. So what I will do, I have to now stop sharing and go to another slide. Stop sharing. Okay. Now you can see this slides, right? Can you see it?
Yes, sir.
Okay, very good. Yeah, right. So now butane is over. Now you end up in getting to pentane. Okay. Fine, sir. So this is the pentane molecule. So pentane molecule, you guys know what is pentane? CH3, CH2, CH2, CH3, right? So I will come to the first part. See how people understood pentane. Okay. So initially, this is the way people understood pentane, how they exhibit in the 4 different structures. Okay. This is one form of pentane. This is another form. I will tell you briefly, but I will tell the story which makes you interesting. This is how people drawn and understood how pentane exists. Okay. In this 4 conformers. But it was not coming good to our understanding because one of my friend asked me when I put butane, sir, why you are not taking C1, C2 instead of that you take C2, C3. It was so nice question because C2, C3, I know that it is the middle of the compound. Okay, so if I cut and I have seen the Newman projection, I can nicely visualize half of the molecule in the front and half of the molecule in the back. Very good. But once I come to pentane, it is not that symmetry molecule where I can cut exactly in the half and visualize half in the front and half in the back. That is not possible at all because it has 5 carbons. So people thought we can see from C2, C3 like butane and try to understand. Okay, so that's how this old version of the books, many books will be like this. And even it was hard for our generation to understand how it looks like. But now there was so nice calculations came around. Okay, people did lot of calculations and did experimental work. And now recent papers, the recent papers, the pentane conformers are like this. It is very nice to see. Idhar par kya bhi pata nahi hoega. You cannot even understand how this molecule exhibits or exists. Sorry, I put a wrong word. Exists. But now come to this slide. Now you can understand how this pentane conformers exist. It's a recent, like might be 5 or 6 years before this all work started, and now it is like confirmed. Everyone confirmed. IPAC confirmed that these are the structures. Now you see how this pentane looks like. It's a linear, right? Guys, are you understanding this one and this one? You see, you think this pentane? What is this structure called? Can we like butane? Can we call what is anti, right?
Anti.
Anti-periplanar.
Yes, sir.
Right, anti-periplanar. But I cannot understand that there was no interaction. I still see there is some interactions here going on, right? It was very tough. But once I go to this conformer, you see this, how it looks. So there is no interaction with this. It's a straight chain linear compound, right? So there is no Gauch interactions here. So that's why we call this structure is a simple anti-structure. Okay. Fine. Okay. Now another conformer, how it comes, one of this C1, C2, which we are talking this part, okay, you folds up this particular methyl, you can fold it up like this, okay, then you get one of the Gauch form. This is a single Gauch form. which we can correlate with where the one which I am correlating with the 1-methyl one. The form which I have discussed with you, which form is this among this?
B, sir.
B, sir.
Sir, B, sir.
B, sir. Are you sure?
C, sir.
Why B, sir?
I think C, sir.
You look now, that's what I am saying. Now look into the Gauch-butane interaction. How much Gauch-butane this will have? 1 to 1, okay? But here you have only one Gauch is there. Okay? So that's why this was really confusing for
Can you
us when we
explain this
studied.
again, sir?
Sir, what do you mean by one Gauch?
See, how many, what is the Gauch interaction? What I said Gauch interaction is, that class, it's a 1, 2, 3 bond interaction, right? So now if I take this methyl, it can have an interaction 1, 2, 3 with this hydrogen. This we call as a Gauch interaction, right? Yes or no?
Yes, sir. Yes.
Yes, sir.
Yeah. So that you see the bond. I am showing here Gauch interaction. That's why I took this example. You have a single line, this methyl group interacting with this. This is called Gauch interactions. Okay. Oh, sorry, I have not taken the laser. Hey, you should have told me, man. I was showing something without the laser. Okay. These are the interactions we are talking for Gauch. Gauch is what interaction? 1, 2, 3 bonds, right? That interaction we talked with this methyl, 1, 2, 3 bond. You can show there is only one Gauch interaction here. Fine. Now you take this guy. How many interactions are there? Now you have one methyl. Once you get a methyl, you should be careful. There will be methyl in axial. You can also consider this as an axial. When methyl comes in axial, you should be careful. That methyl will definitely have a Gauch interaction. Okay. So now this methyl, how many interactions it has? One for this methyl, one Gauch interaction, and one for this methyl, another Gauch interaction. Now how many Gauch interaction you got?
2.
2.
Yeah, very good.
2 interactions.
Now, yeah. Now for this is very interesting molecule. Now we got a new term. First, you tell me how many Gauch here you can think of. Because 2 Gauch, 1 methyl is this direction. So one for this and one for this, right? 2 Gauch you got it. But when I calculate the value, I didn't got 1.7. Instead of that, we were getting 3.5 kilocalories. So I will go back to the Fischer-Newman projection. So see, this has no Gauch, okay? So I removed it from that. This I can say I have 1 Gauch, okay? And this 2 should have only 2 Gauch, right? Both are same, right? Any difference between A and B? Is there any difference between A and B? One is kept this way, another is kept this way. Do you see any difference here, A and B? Sir,
No, sir.
leave it C and T. Now we are finished. D का पास Gauch है नहीं है, C का पास एक Gauch है. But if you look into A and B for me tells that it has 2 Gauch. One for this methyl, another for this methyl. Okay, 2 Gauch both should have. But one of the form gives me 1.7 kilocalories, but another form gives me 3.5 kilocalories, which is entirely different. So what should be the reason? People, you cannot explain this by Newman. It was very tough for people to explain by Newman. Projection man.
Sir, A is showing something like eclipse interaction, no?
Yeah, not that much to have that. Because others also, the way I write, then that also will show eclipsing interaction. That you leave this eclipsing hydrogen. Okay, this is not much. It is not over this one. It should be a little bit down. Okay, if you draw properly, this hydrogen will be away from this hydrogen. There is no eclipsing there. Something more is there, which has like taken it to that level. Then people start understanding.
Sir, the van der Waals repulsion between that CH3 and CH2.
No. Now that's why what happened is that I will tell you what is happening here, which made it to 3.5. See, this is the anti. See, this is the best model right now we have. Okay, don't worry about the anti. I will teach you the terms later. When you draw this two gauge form, okay, this is the CH2, CH3. See, sorry, this is CH3, CH2, 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 CH3. And if you draw like this form, they are seeing that there is a nice interaction between a methyl and methyl, ethyl ka methyl, which we were not able to see, and the simple methyl and CH2, CH3. That two methyl shows a very strong interaction. And we know that methyl interaction is almost around like 3.53, around that region. So that interaction we call the syn-pentane interaction. Like Gauss-butane interaction, there is another interaction which is called a syn-pentane interaction. Sir, very important slide. So this is called as a syn-pentane interaction. The interaction between the methyl and the CH2 of the CH3. These two methyls interact, then this is called a syn-pentane interaction. Okay, that's why. So this methyl, if you look into this is a small molecule. If you look into this, the methyl of this and the methyl of this group, they have a very strong interaction, and this is called as a syn-pentane interaction. Okay, so if you take your anti form, okay, anti whatever you call it, anti, it has 0 gauge. And if you, 0 gauge, and there is no gauge interaction there. If you take the single gauge, we can call, see this gauge people call us, if it is up, people call us minus gauge. That's okay. So this is basically minus gauge and anti straight formum. So this has 1 gauge. This is having 2 gauges, okay, plus gauge and minus gauge. This also has 2 gauge forms. Fine, but this has a methyl interaction. That's why this has the energy. Now, if you look into the energy carefully, this is the best form by which. Yeah.
Sir, when we call it minus gauge or plus gauge?
Yeah, I will come back. I will come to that. See, normally to differentiate these methyls, okay, most of the time people say, like trans, you can say, but it's better that people say one as a plus. If I put this as a plus, the down is a minus. Okay, that's all. So you call this as a plus and minus gauge. This you can call both are plus gauges or both are minus gauges. That's all. Okay, 2 opposite directions you are showing to the methyl. Clear? You can call this as a plus gauge or minus gauge, whatever you want. That means 1 gauge is there. In this case, how many you will show? How you show? This case, I can show 1 gauge is in plus sign, another gauge is in other direction, so I show it minus. In this say, how I show? Both the gauges are plus only, like that. It's only that sign, okay? No need to worry about it. I don't worry about this signs because people say that this is plus and you see this word coming this direction, so you can call this as a minus, okay? But don't worry about the plus or minus that much because it is all about the one plane interaction. So if you look into this gauge, what gauge it is? Because one is going this way, one is going towards me. So this people call us plus gauge, this they call us minus gauge. In this case, my plus gauge, both are the thing, plus minus. This is the same, you can call us plus or minus. But this is all form. This is, I'm not talking about the name. Name is more confusing. But have you know the interaction now, right? Any problem with the interaction? One is straight chain, so you don't have any interaction. So you have a 0 gauge. In one case, I kept the methyl up, okay, because there is a chance of taking this methyl and putting up. Once I put a methyl up, that is an axial. You can think of axial. So I can say there is a 1 gauge here, and I can bend this methyl down. So then I can say there are two gauge here. I can flip them like a V shape, not exactly V in the plane. One V will be one wing is on one plane, another wing on one plane, not big difference. Then you call this as a two gauge system, but here you can see syn-pentane interaction. Okay, that is well and good. This is the best way to understand them. Okay, now coming to the projection. Okay, can I understand by Newman projection, or can I understand by straight chain like this projection? See, this projection, I think it's over. People are. It's very tough to understand this type of. For example, you see here you can show the methyl-methyl interaction. Can I show here by this way? Right?
No.
Yeah, it's tough, but still for understanding, I can understand that there is some methyl-methyl.
If you
That
use
is of drawing.
Use a pen to draw here, it would be easier.
Okay. Thank you. I will use it. So I can show this methyl-methyl interaction in this direction. So syn-pentane I can show here, right? Yes or no?
Yes.
Yes, sir. Yeah. This is now you are started understanding only after seeing this. Before that, you were not able to understand this. But here you cannot show this methyl-methyl interactions far away. So you cannot show this. Here you can show that this is a syn-pentane interaction here. Along with gauge, you have a syn-pentane interaction. That's why you show this form. Fine. Now come to the real way how people do in any books and all these things. People for pentane going for Newman.
Excuse me, sir.
Yes, sir.
Sir, so even if A is eclipsed form and B is staggered form, still B has more energy than A. So that's because of syn interaction.
Syn-pentane
interaction. Okay, sir.
Okay. Now I will finish it and then I will clarify all your doubts. Okay. Now this is the best way people are projecting. In any book, good books or anything right now, this is the best way you can project. Okay. And this is the linear molecule. What this is? The linear molecule where CH3, CS2, 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 CH3. This is linear. Okay. It's a linear molecule. Fine. So this is called as anti-anti. There is no gauge here. There is zero gauge in this case. Fine. Now this case what happens here? In this case, so you can project one. I can take this methyl and I turn this across. Okay. So now you can have these interactions of this methyl with this gauge. Okay. One bond, two bond with this gauge interaction. So it has one gauge interaction. So that's why I call it as gauge. One side I have turned it up, so I call this gauge. Other side I have not done anything, so I call them as an anti. It's still in the anti form. So this is gauge on anti.
Sir.
Yeah.
Sir, here the methyl which you have circled, it interacts exactly with which group? I did not understand that.
What is the third bond connectivity? Gauge is what? 1, 2, 3.
Okay, so it interacts with those bond barometer.
Yeah.
Okay.
Yeah. So now here you see, here I have flipped this methyl again. Okay. In this from here to here, what I did, how I went here to here, just flipped one of the methyl up. So I got one gauge. From here to here, how I went, I can flip two methyls up. So one methyl I flipped it up this direction, another methyl also I turned it around. So I get two gauges here. So this is two gauge interactions. This is gauge and gauge. But the signs you say both will be the same direction, same size. So you call them as a plus or things because of the I said one will be this, So don't worry about that. This will be Gauge plus and Gauge minus. But be careful with the methyl. Okay, that is very important here. The one with the methyl coming together is more important. Here you see, here the methyl and methyl are coming together, so it will be Gauge and Gauge plus it will have a syn interaction. So if I ask you to tell the energies, this will be 2 Gauge plus 1 syn. This will be highest energy, and this will be 2 Gauge, next highest, and this will be 1 Gauge, and this will have no Gauge. So the least energy conformer will be this guy, minimum energy conformer will be this 2, and that's what. So any doubt? Now we will clarify all the doubts before I go to anything. Any doubt? Sir, important sir, butane, pentane, you will get questions. Take it guarantee. Understand them in detail properly. So anti-anti will be more like a linear chain. Gauge anti will be 1-methyl up. That's why I somehow I managed to get this so that it will be good for you. Okay. So just look the name here. Don't go with the image. Look the name. Anti-anti, once you see, you should say the molecule is linear. Once you say Gauge anti, you should say 1-methyl of the pentane is up. Like this. Okay. Once you see Gauge and Gauge with no pentane interaction, then you say one is, both are in the same Gauge plus and Gauge plus. And another you do will be a V-shaped one where 2-methyl interacts. That will be Gauge minus and Gauge plus with a syn interaction. So if you see the Gauge minus Gauge plus with the syn interaction will have highest energy repulsion, highest energy, and the Gauge plus and Gauge plus will have second. Gauge and anti will be the third, and anti-anti will be the last one. So the least energy conformer will be anti-anti. The minimum energy conformers will be anti-anti and Gauge anti. Any doubt?
So can you explain what the plus and minus here are with Gauge?
Yeah, that's what I said. If you go into that detail, see this one, what happens? See, this is more like, okay, point. Okay, you look, okay, sir. See, this is the easy way to understand, but not the tricky. So you take this one, this methyl and this methyl. How they are projected, you have to look. Both will be actually, if you look into them, both will be the same plane only. Okay, so that you can call them as plus plus. Okay, this two, this will be the more like a same plane. Okay, but in this case it's not like that. 1-methyl will be in this direction mostly out of plane. Okay, and this methyl will be in this direction out of. That's why I call this as plus or minus, nothing big. Okay, this methyl is going this way and this methyl is going this way. Fine. Here both are like in the same plane. One is, these are all in the both the same place. Isme jara, it will be V like bend one. So one is projecting that direction away from your screen. Another is, this is away from this side of the screen. This is away from this side of the screen. Clear? So that's why I give this plus plus and this I give as minus plus. But that you can easily understand. If it is a syn interaction, it will be minus plus. No need to worry. Any doubts, sir? No doubt, right? If you don't say, are you clear? No answer.
Yes, sir.
Yes, sir. इसका पास भी positive answer नहीं है. Looks like you are not clear. Clear, right?
Yes, sir. From this one it is clear. This this diagram that is seen printed in page.
Huh? I'm not getting
So
you.
from this, yes sir, it is clear. It is.
Okay, okay. That's why I given the 3 projections so that you. For me initially it was tough, but seeing 3 projection I was very clear. Yeah. So that's where the whole thing comes. Nice. Okay. Now. Okay. Now I will rush through some things which are which you know before in hand, so that next class we take some interesting things. Okay. To the cycloalkanes. Okay, now this is all this aliphatic conformers we have seen, the straight chain compounds. Now we will see the cyclic systems. Okay. Yeah, I will take 5 minutes extra because I started the class late. Okay, fine. So cyclopropane. You guys remember this degrees, right? No one is going to ask you, but still, huh? N-2 divided by N into 180 degree.
Yes.
Okay, fine. So how cyclopropane? Yeah, very nice. How cyclopropane exists in in real?
Planar.
Huh?
Planar, sir.
Planar. That's important. But how they exist? They exist like a triangle.
Sir, banana bonds.
Very
the
good.
bonds are.
Yeah, cyclopropane cannot exist like this. It's very tough. Okay, you cannot have a 3 bonds here. It's very tough for them to have a 3 bonds because of the repulsion they have. It's very tough to have these 3 bonds. So what they do, these bonds will repel, and to minimize the strain, what they do, they exist basically. So basically they have a torsional strain, which you know what is torsional strain. But now you understand there is another term called angle strain because it is only 60 degree. So to accommodate this, what it does, it basically exists like a banana. This is called as a banana bond. Okay. Because of this banana bond, what happens is that you can break this bond very fast because of the poor orbital. That's why cyclopropane, if you do a reaction, it opens up very fast. Okay, because of the banana bond. To accommodate the strains, the bond gets little bit out of the plane, not out of the plane, out of triangle, to accommodate this, so that you end up like a banana bond, which leads to a poor orbital overlap. And this. Now the question which you have to remember here is that how much diversion it takes. The electron density, how much it is diverted away from the ring, how much this diversion takes place. That is very important for us. So that happens by 21 degree. Fine. So now the question we ask you is that cyclopropane, what are the strains there in cyclopropane? You can see, I will say most of the time there are torsional strain and angle strain. Okay. And how much electron density diversion it takes from the ring. So it by 21 degree. Sir, I don't know, sometime we might ask you the degree also. You might say that, sir, it's not memorizing, but still, sometime I have seen that for certain previous semesters we asked this question, how degree it is. Okay, it is by 21 degree. Okay, fine. How the cyclobutane exists? It exists as a square?
No, sir, in Behalf. No.
No.
Sir, you have already formed twisted form.
What's that?
Sir, you have already shown in the slide. It is not square.
Yeah, it's not a planar. So what are the angles?
Puckered.
Yeah, puckered one. So torsional strain and angle strain, both the strains are present like cyclopropane. Okay. To relieve this strain, what they do, they exist like this. Okay, like a puckered structure, puckered square. And again, the point here is that the angle, how much interplanar angle it is puckered from the plane. That is what we're going to, that only you have to remember. That is 35 degree. So cyclopropane, the electron diverts from the ring by 21 degree. For cyclobutane, it gets puckered from the plane by 35 degree. And what are the two strains which are involved there? One is torsional strain, another is your angle strain. Fine. Okay. How cyclopentane?
Sir, in Vela form.
Envelope form. That's all. Any other form? Cyclopentane? No. Cyclopentane. So cyclopentane exists in two forms most of the time. One is your envelope form, another is your half chair form. What it is? Envelope form and half chair form. And these two forms interconverts rapidly. That's why you don't see them. Both, okay? But both are exist. So whenever people ask cyclopentane, please don't say envelope is already allowed. Envelope and half chair both are there in cyclopentane, and they their stability and energy interaction, if you do, it is almost same. They interconvert very rapidly. Sir, again I am saying, because if I repeat, you should understand something important there. So cyclopentane exists both envelope as well as half chair form, and both these forms interconverts very rapidly because of the same energy or similar stability. Okay, this is about cyclopentane. So I can, so can I, so that's what I have to take in this class. So any doubt? So what we have discussed in this class, we have discussed about the Gauch-Butane interaction. We have discussed about the syn-pentane interaction. Please go and look into this Gauch-Butane, syn-pentane interaction. And I have discussed about cyclopropane degree, 21 degree, and cyclobutane ka 35 degree. Okay. So, and then cyclohexapentane, I said that it exists both in the half chair and envelope, and they are same energy, so they interconvert very rapidly. So that's the take-home message of this class. Okay.
Sir,
so any doubt?
I cannot understand the half chair conformation in three-dimensional view of cyclopentane.
Half chair you will understand once I take cyclohexane. Don't worry. Okay. Next class I will take cyclohexane. There you will have half chair.
Okay.
Sir, can you once explain the Gauch antiform in the syn-pentane interaction?
You want me to explain again?
Yes, sir.
In what sense? Explain again means in what sense?
Sir, that
You
one
want
Gauch
to repeat
is coming.
Repeat again?
No, sir, that only the Gauch antiform.
Just a minute. Share the slides. Yes, madam. Yeah. What you want me to say here?
So the Gauch antiform.
This Gauch antiform, right? How this Gauch antiform looks like? If you look this slide, you see this one. So this we can call as anti because it is away from everything. It's away from each other's, right? So I have taken one of this methyl and made it axial. So this goes to axial now, right?
Yes,
so
sir.
we know that this will have now Gauch-Butane interaction.
Yes, sir.
Yeah, so this will have a Gauch-Butane interaction. So there will be only one Gauch-Butane interaction here, right?
Okay, sir.
And the remaining forms are out there. Remaining are anti only, right?
Anti, yes, sir.
Yeah, that's why I call this as a Gauch antiform. And one Gauch, so I give them 0.9 kilocalories per mole. So now what I can say, why cannot be, you said that I have moved this bond up, this methyl, the end methyl. You can always ask me, sir, why cannot this methyl I can move? Yes, then we draw a conformer where I have one methyl up and this methyl also I can bend it, right? But both are in the same plane. They are not in different plane, okay? Fine. So now this methyl will have one Gauch. Then this methyl also should have one Gauch, right?
Yes, sir. So
yes.
2 Gauch.
So 2 Gauch. Now, since I am saying these two methyls are on the same plane, can I call this gauge as gauge plus and this as gauge plus?
Yes, sir.
Because both are same. But so I can use the plus terminology here to make them both on the same plane. Yes?
Okay, sir.
Okay. Now I move to another form where I have observed this form by, okay. What happened here? Here I have seen that there is another conformer exhibits which has an higher energy. Fine. So how to explain this? So people do a lot of experimental work and people have done a lot of calculation and they came out with a nice structure like this, which they say that it will be more like a V-shaped, okay? More like a V-shaped.
Yes, sir.
Okay. More like a V-shaped, where one of the side of one V wing is pointing towards, for example, pointing towards the away from the PPT, another towards me, right?
Yes, sir.
Yeah. So here I can say it is gauge plus, I can say this gauge minus. Okay,
Yes,
very good. Now in this, then I should have only two gauge form. That means it should be
2 gauge.
yeah 1.8 kilocalories.
Yes.
But still I am seeing 3.5. Then finally I am concluding that the methyl of this one and the methyl of my, these two methyls are coming somehow close to each other to have a methyl-methyl interaction. That's interaction we call them as a syn-pentane interaction. And that is almost, people are saying that can be of, this is little bit away from each other. It's not like a eclipsing interaction, which is 3 kilocalories. This is not eclipsing. This is more or less like a syn-pentane interaction, which gives you another 1.5 kilocalories. Okay, so you already 2 gauge gives you 1.8 and this gives you another 1.5. So almost like 3.3, but experimentally it is 3.5. Are you getting it?
Yes, sir. Got it, sir.
Okay.
Thank you, sir.
Yeah, no problem. Any doubts, sir?
So the syn-pentane interaction gives around 1.5.
Yeah, 1.4, 1.5. Because that methyls are not eclipsing, they are not close. That's why I said one methyl is moving away from another methyl.
Yes, sir. Yes, sir. Opposite direction.
If it is, yeah, if it is eclipsing, then I should have given 3, ne?
Yes, sir.
Yeah, that's why.
Sir,
Well,
sir,
yes,
one
sir.
more doubt.
Yes, sir.
Sir, here in case of pentane, do we means name the conformers like anti-eclipse, partial eclipse like that, or we just follow this convention 0 gauge?
Yeah,
1 gauge?
this is the right now people using this conversation. Initially, people were using this eclipse and all these things when they used Newman, right? That time
So
they were
means-
using Newman prediction. They were saying fully eclipse, partially this all. But right now, this is the best way because people accepted this. This fits with many things.
Okay, sir. For pentane, we can safely follow these names which you
Yeah,
have
these
given.
are yeah. This is the best way to follow pentane.
Okay, sir. Okay.
No doubts, right?
Excuse me.
Yeah.
Hello.
Yeah. I'm not able to hear you.
So then for each means like hexane, then we have to follow different convention. Also, means we follow different convention, or is this continued?
No, I am not hearing you. Anyone can, anyone who has heard this question can let me know. Hello?
Yes, sir. I am audible.
Yeah, you are audible now. Yeah.
Sir, so we follow this convention from pentane till means hexane, heptane, octane.
Yeah. If it is a straight chain, you can follow this. It works nicely.
Okay, sir.
Okay then, guys. So thank you. Thanks a lot. We will meet tomorrow by 10 o'clock and we will try to understand cyclohexane and substitute a cyclohexane. Okay? Come with a fresh mind tomorrow.
Thank you.
Okay then. Thank you. Yeah.
Thank you,
Sir,
sir.
please give this slide. Sir, you will give these slides, right?
Yeah, tomorrow I will upload because tomorrow is done. So I have to upload all the slides. Okay?
Okay, sir. So please give.
Okay. Thank you. Bye.
Thank you, sir.